Hello guys, in this video I will do a breakdown of how I created this stack books generator, and let me quickly show you what it can do. So I can enable a debug plane where books has been placed onto or spawned from, so I can resize the spawn area where the books will be placed. I can randomize their placement with the slider. I can increase the amount of books, stack books to spawn. It's basically the amount of how many points to scatter. So I can spawn just one stack and then nice. I can spawn 20 stacks, 15. So yeah, I will disable the debug plane. I can also change the seed to control the amount of books on each stack. I can control the minimum and maximum amount of books per stack. So as you can see, there is the minimum of one book needs to be in the stack, and the maximum is 10 books. So I can change the seed. And the same thing is for rotation. I can play around with the rotation per each stack. I can control the amount of rotation, and it will be slightly different. After that, I can also control the minimum and maximum width or thickness or height of the book. So, for example, min y and min max, or min y and max y. So it will make the books a lot thinner. And I can play around with the seed value. As you can see, some of them are thinner, and some of them are thicker. And same goes for the x and z values. And I can also enable coloring, as I call it. As you can see, every book has now a random color applied to it. And I can control the seed. I can make it black and white. This is something that I'm still exploring. So basically I will share my current exploration and what I have found. So I can control this. Yeah. And if I increase the amount of stacks to something like 7, this will still work. And yeah, let me actually show you how it looks like inside of Unreal Engine. It's a project I'm currently working on. Here's a simple scene, and by default, the output geometry when it's inside of Unreal Engine, when it's baked, it will create a Nanite mesh using a Houdini engine some attribute which I will show you. And so this is the exact same books from the Houdini interface that I showed you. And as you can see, when I baked it, it has created a Nanite mesh. So here's some under Nanite visualization, and I can see triangles. And yeah, so let me actually walk through how we created it. So here is the whole setup, not so big. So basically we have 2 loops. For each loops, this one to create colors, this one, and 2 loops like this, and to randomize the colors. This is a second for loop, and the first one is to randomize placement, the amount of books per each stack and size of each book and stuff like that. So to create this area where books will be placed and then resize it, it's pretty simple actually. And all you have to do, first of all, to create a box, and this box will be as our guided geometry where books will be placed on. And then you have a node which is called labs split primitives by normal, and basically I'm selecting the bottom face of the box, this bottom face, by setting the direction to -y. Then I'm placing this on top of the world origin using the match size, and under justify y I have selected the mean option, and justify x to none and justify z to none. It could be set to default, but I set it explicitly because I don't need to move the geometry in other directions except y direction, and this is why I have changed the value to none. And after that I created a null which will be used here, and basically this null is to use an object merge and color it, and it will be used as a guide geometry for debugging purpose, which is this toggle. So it basically creates, it basically gives an idea where books will be placed on. So I have a more clear clue where a box will be spawned. And yeah, and then I'm using a scatter node to create points. And here I have used exposed force total count. So now I'm spawning 7 points. And the global seed is controlled this, basically where books will be placed. This is what this global seed does. So the first loop, this loop is for each point. And under for each begin, I have also created a metadata node, which allows to get an iteration number from the detail attribute. Here. So, and this iteration number will be heavily used inside of this node. As you can see here is quite a lot of happening, but actually it's simple. I will walk through each of the steps, and you may want to rewatch it several times, and it will make a lot of sense after a few times. So basically, what's happening here is that I can actually disable this nodes, and without a debug option, which is this one, this toggle, which uses these nodes, there are only 5 nodes being used. So, and to keep things simple, I will focus only on this part right now. So what's happening here is that here I have points, and this for loop iterates over each point, and after that I'm using a copy to points to copy this stack of books, which I have an HDA, which is exactly about stacking books on top of each other, but you can use a single book. Here I actually removing all of the books and creating only single book here. You can use like a box to experiment or something like that. So here I'm placing this geometry on each of these points, on each point here, and this is what we get. And here I have a controller which controls everything here. And the reason I have created it is just for the sake of simplicity and to better understand where things are located. So I can actually create additional parameters here under this HDA, like temporary parameters, like drag and drop something from here to here. But I didn't really want to do something like that or approach something like that. So for me, it's actually was much simpler to create a null, like a null, and edit parameter interface, and then drag and drop whatever I needed, and then rename it. By renaming it, I mean give a name, which will be a parameter name and a parameter label, and then I can reference it inside of this HDA, like in these expressions. And so what I'm doing here, so every single of these expressions, like this one, this one, this one, this one, is using the same idea, which is let me actually show you on a simple book or on simple box. So I'll scale them down a little bit. So what I have done here is, first of all, I have created a spare input. So click on this gear icon, then a spare input, then drag and drop the for each begin metadata here. Now you can type something like this. Now we're accessing iteration number. As you can see, per each iteration, we're increasing the Y size of the box. And this is the first iteration number. And I can see it by using a single pass option. As you can see, the first iteration, and the size of the box is 0. Then the size of the box is 1, 2, 3, and so on, until it hits 7 or 6. Now, how to control it? How to make it like from certain size to like from the minimum to maximum size? How to control it? First of all, we can use a feed function expression to control the maximum and minimum size. So you need to specify I don't really remember what it does, and you can check out documentation on what it is, but basically, so this will be our minimum. Oh, this is old minimum and old maximum, and this will be like, now right now we are typing a new minimum Y size and new maximum Y size, like this. So we remapped our iteration number to be from 0.1 to 0.7 instead of 0 or whatever it might be. Here I'm actually not really sure how to explain this part. You can better check out documentation or other people explaining it. But in most basic terms, the feed function, using feed function, we're creating a new minimum and maximum values. And this is what we've done here. And we can type here whatever we want, so 3. So the minimum will be 0.0, 0.1, and the maximum will be 3. And you can type something. You can type the same here into other parts. So into the X and Z, but let's type into Z like so. This is what you get. Now, as you can see, some of them are identical, like most of them, and we can randomize it using rand function before the feed. Now it's slightly different. And how to randomize it even more? So we can use the seed value, and to create a seed value, we need to actually create a parameter, and we can call it seed. And call it something like that. So now you have here an additional parameter under the box node. And if you create another box, it won't be present here. It's just for this specific node available. Now you can copy parameter of this seed value. And after the rand function, this, before. After the detail. So this is the detail function expression. You can add the seed value like so. And now we can randomize it and to see what we like more. So first of all, we are accessing the iteration number, then we add in a seed value. Actually, a lot of is here. Then we add in a seed value, as I said. Then we randomizing this value, and the rand function will create a value from 0 to 1, as far as I remember. And then we remapping this value from 0 to 1 to 0.1 and to 0.7. So we're actually controlling, and this is what it does. And this is what happens exactly here. The exact same process. Actually, so typo here. As you can see, it's exactly the same thing, except here I have also added a channel reference for the minimum value and for the maximum value. You can also create here, this is like what it actually looks like. And you can also create a minimum value here, like to control it from parameters. Yeah, and this is how I created it. And this controller's expressions and this controller parameters is being exposed to the HDA level to here. And to actually create a stack of books, you can do something like this with another for loop, which will be in the beginning before everything here. So this is the simplest setup as it could be. So this is for each number, this for loop. And what I have here is that a simple box. I have switched it a lot, and then I plugged it into the for each begin node. And here's where the stacking will be happening. So under for each begin node, you need to make sure that the method is set to fetch feedback, which is basically the previous iteration of the for loop. And under the for each end, the gather method is set to feedback each iteration. And iterations will be basically how many books to stack on top of each other. And to stack them on top of each other, we'll be using a match size. And the geometry of the bounding box will be the output of the for each begin, which is basically the previous iteration. And the other part will be this, like the geometry to move and resize will be the input geometry or original geometry. But I have plugged it into this transform to randomize scale and rotation, and this is like everything I have shown you before, like details attribute, detailed attribute, randomization expression, and the fit expression. So basically, I'm remapping random value from the iteration number to minimum and maximum value here, and the same for the y, and the same for the z, and for the rotation exactly the same thing, but except of hard coordinate, like writing constant value. I have added a channel reference, which basically these three parameters here. So I can control the minimum and maximum rotation here. And yeah. And I can control the seed. And the seed is basically after the detail expression, I'm also adding a seed value. And after you've done a match size, so the bounding box is a previous iteration or the first iteration. And after that, we need to merge previous iteration with the current iteration of the for loop. Like this is the first iteration, so this is book, like original box. And after that, we merge original box, like this bounding box, with the current iteration, like this second box. And yeah, so let me disable it and use this. And now you have here this. And you need to also randomize the iteration number to have random number of books per stack. This is what I have done here. Actually, let's copy paste it and let's see if it will work. Let's disable it for a second. Minimum, maximum. Yeah, kind of works, but not as expected, I guess. Oh, this is because I don't have this. I don't have a spare input, because detail -1 means that it's a spare input. And now, as you can see, you have a different amount of books. Okay, minimum. Let's make like so. Now it works. Oops, minimum 1, maximum 10. Yeah, now it works as expected. And yeah, let's move on. And now about the debug option here. So to create a debug guided geometry where books will be placed, I have created a switch node to switch, like to enable or disable this guided geometry. To do it, you can create a toggle. Here I have already one. Then copy parameter of this toggle, paste relative reference. And now when you click on the toggle, the switch will be directed to these nodes. And what I have done here is I have used the object merge. So instead of doing something like this, which is not really pretty looking, I have used an object merge to reference this null. Then I have added a color. You can use whatever color you like. And then you need to merge books with the guided geometry. And this is the result. And this is how you can create this debug plane here. After that, another for loop begins. And this for loop is to create colors. I won't be explaining too much about what this node does, because it will be out of this topic. And the only thing I will explain about how to create these colors. But essentially, I have created a separate HDA to create an ambient occlusion for the whole stack. And stuff like that. And to create a randomized color, you need to also create another for loop. And this time, another type of loop will be used for each connected piece. So here we actually will be iterating over each separate book. Like, through every single book. And you need to also have a metadata node, and to create it under, you can create it under the for each begin and create import metadata node, and if you don't have it already. And after that, you can use a color node like this, and you can type everything from here. Oops, forgot about this pair input. And now you have basically the same thing, except, oh, I forgot to specify the group to color. So before it was like so, and after that like so. So I just specified the color to color the color, and now you have the exact same thing, basically, but with the color node. And essentially what happens here is exactly the same as here. Again, I'm accessing the pair input, but for the second, from this to the second node. And then I'm using first of all, I'm accessing the iteration number, then I'm randomizing this value. Oops. Then I'm randomizing this value. and also adding a seed, and then additionally adding a global seed. Let me actually delete it for now. So this will be the global seed for every color, and this R and G and P seed will be specific to this, this, and this, and then an additional global seed to vary this value, each of these values. So I can control each of the channel seed, and then I can add additional seed to control everything here. So this is what happening here. So everything here is the same except from this channel reference. So basically changing the value. And after that I have added another stylized coloring. This is not really related to the breakdown. And here I have also created the same controller as here, but to control the seed for each channel R, G, and B, and the global seed. Then I have cleaned all of the groups except of these groups, which is only related to the Stackbooks HDA. Here I'm basically creating 5 groups for 5 real materials to randomize it. It's just basically creating a random group for each book, and then I can apply Unreal material, and it will apply to the random selected books. And here I'm creating everything except normal, UVs, another normal for some reason, and the color data. And the color data is basically comes from here. And if you will be using a color node, this has to be also be here. Then I'm using an attribute create to create a Nanite mesh, as you saw in the beginning of the video, where I have showed an Unreal Engine scene with a Nanite overview. And to create a Nanite attribute, like when you want to bake the asset, you have to create an attribute create node. You have to add an attribute create node, and under the name, you need to specify the Unreal Nanite enabled, and you need to change the type. Actually, it should be, I guess, an integer, and this should be primitive. But for me, it worked. With the default values. But yeah, so I have changed the default and value from 0 to 1 here and here, because by default it looks so. And here I have also experimented with the Unreal baked folder, which haven't worked for me for some reason, and this is still something I'm exploring. So yeah. And finally, I have created a collision geometry. Well, to be a collision geometry for the player. And all you have to do is to add this group name, rendered collision geo, and Houdini engine and Unreal Engine will recognize it as a collision geometry. And you can create a preset, so you don't have to type it every time. And yeah, this is how you can create a stack of books from the input area. And yeah, hope you learned something out of it. And let me know if you have any questions or confusions in the comment section. See you in the next video. Take care, have a great day and great life. See you.